Welcome to Ask and Learn.
So they give us the integers with this ordering where x is strictly less than y if and only if the absolute value of x is less than or equal to the absolute value of y. Okay, so they tell us that they want us to show that this is well-founded but not well-ordered. So well-founded, you can find the definition right above this problem. It essentially just means that there are no infinite decreasing sequences of elements in the poset. All right, so what we want to do is actually, so I think it's easier first to show why it's well ordered, and then once we show that, the rationale for that will be a little bit better for explaining why it's well founded. All right, so what we're going to do is, so for well ordered, so remember this means any subset of Z should have a least element. All right, so we have that. Well, what if we just had the subset 2, -2, which, so this is a subset of Z, but this is going to have no least element. Well, in this case, we wouldn't have that the absolute value of 2 is less than absolute value, or the absolute value of -2 is less than the absolute value of 2, nor do we have that the absolute value of 2 is less than the absolute value of -2. So this implies no least element, or is set -2, 2. All right. Now, for showing it's well founded, so what we're going to do is just let A be any sequence in Z, any sequence of elements in Z. Well, if we think about this, if we take the greatest lower bound of A, this has to be greater than or equal to 0. Since if we just have the absolute value of any number x, this has to be greater than or equal to 0 as well. So since we have a greatest lower bound for any sequence, we cannot have a infinitely decreasing sequence due to, so if we were, it would look something kind of like, I don't know, like, so in, and so I don't know, maybe we have some stuff over here, so dot dot dot. Well, then it would be n -1, n-2, dot dot dot, or maybe instead of n-1, n-2, and all that, I should say, actually no, yeah, we'll just do that. So we have something like this, n-2, dot dot dot, all the way down to, and then it would be like 2, 1, 0. But then at this point, it stops. We can't go any further because that absolute value got rid of all those zeros. So no matter what the sequence is, every single time we hit 0, and since we don't have fractions, that it would just have to be like 1 or 2. So if there is an infinite sequence, that's, so, well, you can have one increasing for this, but you can't have one that it's decreasing. And so since this is the case, this would be well founded.